Well, good evening, everybody. So tonight we're going to try and get the entire DC side of the system up and running. So let's get started. Well, in our last couple of videos, we've taken a look at the new Victron 10 kVA kit that I received from Current Connected. And then last time we went through and actually got the brand new 8x8x72 wireway all prepped and mounted. We got the conduit in, we've got the inverters up on the wall, the charge controllers up on the wall. We also took a look at this new bus bar layout that we're going to be installing. And in this video, we're going to be able to actually get that bus bar system up on the wall mounted and then get all the cabling run from the different components to this bus bar system and get it all powered up. So I'll let you know right now, it's going to be a little longer one. There's a whole lot of stuff to try to cram into this video. So grab your popcorn, kick up your feet, and enjoy the ride. All right, so I think I have how I'm going to lay this thing out. I ended up drilling holes in the bottom of the wireway for the battery cables. So I ended up ordering some more of those same size grommets because I need one more up top here and then these three here. I was trying to use these gray pieces here, but when I used the hole punch for a 1-inch hole punch, the holes end up getting punched for what, 1.25 inches outside diameter. These seem to be actually around 1 inch. So I probably could have used the 3/4 inch hole punch and those would have worked perfectly, but oh well. The strain relief isn't gonna hurt it. I was surprised when I went to pick this bus bar configuration up. This is not light. It's got some heft to it. I'll grab a handful of screws. So I'm gonna try and keep it just to this side of this gland because I might have a use for these studs here. And I'm gonna try and, for now, follow this green line. Let's try right there. Now remember, we went through and we torqued all these down already. And holy cow, that is like perfect. I never get it perfect by eyeballing it. Sweet. So my goal, like I said earlier, is to try and use the same exact order for this bus bar. So I want the closest one to be the farthest one on the left from this configuration. So I want to make sure, and this is the other downside to having pre-made cables, is they're always the same orientation, and they might not be the orientation you want them to be. Gonna see how this is gonna look and work. So if I can get that first one to work, which it just barely does, we should be able to make this work the way I want to. So let's pull the tab off of this one, and this one. And let me grab the torque wrench so that we can connect these negatives. I will admit that I like having this horizontal instead of having it up and down. I think it just looks better. All right, so we'll flip up this protector. We got our M8 bolt, I believe is what it said, with a 13 millimeter socket. And I believe it's the same torque spec of 14 Newton meters, 10.2 foot-pounds. And then click it down. So you got to make sure that your lug is all the way up against the bus bar. And then when you're doing this, so when you look at these, you see you've got 1, 2, 3, 4. Make sure you don't take this one off, because I don't know if you can see it, but right up top, right there, there's actually a voltage sense wire that's detecting the voltage on this negative bus bar. It probably helps power this board up here as well. But make sure that you're not loosening and using that one. In fact, they've got a different style peg here, so you can't use that. Yes, I just wanted you to be able to see my shirt.
Let me crouch down a little bit here.
No, so I just wanted to make it so that you could kind of see inside the inverters and everything, but you could also see the bus bar connections down here. So I know I don't have these grommets yet. I'm going to try and put some protective fittings in here, or I might even just put some tape around the sharp edges for now, just to run the cables down and get everything connected in to make sure everything works fine. And then I can move on to whatever the next thing is. And no, I know somebody's going to say something. No, this is not staying like this. This is just till the new replacement grommets show up. If I can get to the point that I can do a simple power-up test tonight, that would be sweet. I gotta move this rack though. I will say that is one downside of probably most of your DIY shelf batteries, is that to move them, you either have to completely disassemble the entire pack and move them one cell at a time, or you have to be able to move whatever those cells are sitting on. All right, let me reiterate again. These are temporary, just so that I can try and power things up. The replacement grommets are on their way. The charge controller is 14 Newton meters, and the two inverters, based on the manual, are 12 Newton meters, all with an M8 nut. So the 13 millimeter should work fine. Since we've already got our torque wrench set to the 14 Newton meters, let's just go ahead and get this one connected. Boy, this is a little pain in the butt. It's almost like the stud's too long. You can't get the 5/16 over it very easy, because you can't go up and down. You gotta go at an angle. Yeah, 5/16 is very snug. Oh, I don't want to break anything. Wow, that was not pleasant at all. Wonder how the positive is going to do, because the positive is offset. It's not even directly underneath, so Yep, same thing on this side. It is a bugger. Oh. And it doesn't say anything about connecting one versus the other first. I think these bolts are too long, because the 5/16 is a perfect fit, but it comes out too far. So, you know, when you work on these lugs and after you heat shrink and crimp, you really can't bend anything from here up. Your lugs ends here, but you can't really get any bending in really almost this whole space. So trying to force this in and bend it in when you're having to get it out further than the hole here, it's kind of a pain. So just be aware. I'm going to try taking the negative back off, or at least loosening it so I can move it. Oh, ouch. That hurt. Okay, so and then feed our cable down. Well, it's been a battle today just to keep my phone charged because it keeps dying on me, so I'm constantly having to go through and stop what I'm doing and recharge it and do something else. So this last time, and I'm not letting it charge all the way up, so it's not really helping me much, but this last time my wife and I moved the battery rack from this side where I'm standing right now over to here on the left where it's gonna stay right now. So yes, your camera's not, your image isn't backwards. We switched things around. I wanted to make sure that I could easily get to both of these inverters, get in front, and then have my disconnects and everything completely cleared over here. So we've still got the PV disconnects over there, and there's plenty of room for everything to open and close there. All right, so back to what we were doing. I did look at the manual, and the manual doesn't explicitly state, you know, here's layer 1, layer 2, layer 3, but in the order that the manual flows, it talks about putting the fuse on, and then a few paragraphs later, then it talks about putting your lug on. So we're gonna go with it from that standpoint that it's fuse first, then lug on top. And then it also mentions having a blank fuse or an additional fuse in any spot that you're not using, so that the distributor shows that that is a green spot, a good connection, as opposed to showing red. Is it really that big of a deal? I'll leave it up to you. Let's see here. So this will be our charge controller. So I've already gone through and loosened all these. And I know when I looked at the distributor earlier, I had thought that these fuses were not going to sit well on here, but these studs have some flexibility to move. So that helps a lot. And again, these are 125 amp fuses. I don't know if you could see that very well. So we'll do fuse first. And it does seem like it's easiest to put the fuse on the bottom first, because the top is the part that moves. So put it on the bottom first, and then put your 2 washers, and then your nut, and then bring your bottom, your positive into the bottom. Your 2 washers, and your nut. And here it is. And just like that. So we'll do the other two, and then we'll run our RJ, I believe it's a RJ11, over to the Lynx shunt. I'm not going to put the fuse in the shunt until the very end, just because I don't want any power going across accidentally, just in case, even though I'm going to leave my battery breakers disconnected. Just as a sanity check, red on the left, black on the right. And if I tip it up a little bit, you can see right there, there's a plus for positive. And you can see the red over on this side. And then there's a black shroud on this side, and there's a negative right above my finger. So red on the left, black on the right. Same thing over here. Red on the left, black on the right. And we didn't do it on this charge controller, but there's a big old plus and a big old minus. So it's nice that there's a consistency there as well. Red on the left, black on the right. Unfortunately, that consistency is not over here, but that's fine. Something else to pay attention to on the distributor. This second connection has a terminal already connected to it. I believe this is a voltage sense or a positive lead for this PCB. That needs to stay on the bottom. So you'll put your fuse on top of this, and then you'll have your lug on top of the fuse down here. But the manual says leave that on the bottom. Alright, so one more time, we've got a RJ11, I think, connection that goes from here, and it needs to connect to the shunt over here. So it'll come over, down through this slot right here, and then up through this one, and click in right there. And that'll allow for communication between the distributor and the shunt. And then the shunt will be able to communicate over to the servo. There we go. One piece of the bus. Let's just hold that there till we get it screwed in. One piece of the bus bar down. The shunt will be really easy with just the fuse and then the connection to the servo. And then we've got battery connections over here needed for the power in. All right, we're back for another day, and it looks like we might get power running, at least DC power running today. So I've got my battery disconnect mounted here, top breaker for the top shelf, bottom breaker for the bottom shelf. I was debating on actually mounting it to the side here, but for the time being, I think this should work fine. So we've got our cables down here that we need to run to our Lynx power in. This side is not fused. I believe they're just kind of assuming that you're going to have a disconnect. Very nice thing of beauty. All right, so we can see positive, positive, negative, negative, positive, positive, negative, negative, straight pass through on the breakers. Positive of the top one goes over to that positive bus bar over there, Negative of the top one comes up here into my negative post. Positive of the bottom one goes back over there and over to that post. And negative loops down right up here to this negative post. Now, it's all well and good to have the color coding, but I still want to check everything before we go flipping any switches. So what I'm going to do, we'll turn the BMSs on. We'll pop the cover off here. We'll check for voltage on the bottom of the terminals and make sure polarity is proper before we do anything else. Bottom is negative, top is positive. We have 52.1 volts. Power up the top one. And we have 52.0 volts. So just to make sure that you see this will not power up the Lynx Distributor. There is no fuse here. So it will not go through to the inverters. But we've got our power, positive, and positive, negative and negative, come to the negative bus bar. So let's make sure we've got power on this bus bar here. That's very interesting. So how did we get power over here? Kind of freaks you out. You saw that, right? It turned on. Is it due to a communication cable? Possibly. Guess let's find out if it does it again when I disconnected the communication cable. Okay, so that makes a whole lot more sense to me. Kind of made me think that I was going to blow capacitors in the inverters. So this does supply power to the PCB over here, but not there's no power to the bus bar because there's no bridge here. Oh, good grief. You ever have one of those heart in your throat moments? All right, check negative and positive. 52.1 volts. You can see there's a red light here on the Lynx Shunt. I believe that red light is due to the fact that the fuse is not here, so it's signifying that the fuse is blown because there is no fuse bridging the connection. If I plug this in over here, so that it's in a yellow-ish state, which I'm assuming means that there is no power to the bus bars, but the PCB has power. Ugh. Boy, that can freak you out. All right, we'll turn that off because I don't want any power right there for right now. The batteries are active, but the breaker is thrown, and we'll just let this drain out. I looked in the manual, and I did not see a torque spec for this fuse. So I'm going to assume that it's the same torque spec as everything else, which is 14 Newton meters, or 10.2 foot-pounds. And then like these other studs, once you loosen them, they move around so that you can easily place your fuse. And so the fuse that goes in this thing is a CNN fuse, and it's specifically spaced for a CNN fuse. This is a 325 amp fuse that came with the Lynx Shunt. So place the fuse in. And remember, you need to adjust the size of your fuse based on the amount of power that you're drawing from your battery bank as a whole. So the overall power that your inverters and charge controllers and everything is going to be able to handle. So here's a close-up of the power in. Connecting to the Lynx Shunt. Connecting to the distributor. This is just so massive, it's hard to get everything in frame. I got stuff going all the way down low and then all the way up high. So we've got everything prepped and ready to go. The batteries are turned on, the breakers are turned off. Now these inverters, because they're so large, they need to have a pre-charge before you go and turn everything on completely. And what I mean by that is they have capacitors inside that if you just flip the breaker on, they would just have this huge inrush of current from your batteries that would try to basically fill those capacitors almost instantly, and there's potential to blow the capacitors from that huge inrush. And that can happen with your charge controller, that could happen with your inverter. And so the idea is you want to pre-charge by one of two ways. So one, you could use a resistor, and you basically bypass your breaker to allow power to flow into these devices, but the resistor kind of funnels that flow of power down so that it's just a little trickle, just enough for your capacitors to charge and level out. It won't allow that huge amp surge to go through. Now in my case, I have disconnects going through both the positive and the negatives down below. So in order to do that, I would basically have to jumper both the positive and the negative. And I always found it kind of annoying to have to use the resistor, especially having to jumper both connections. So I ended up watching, I believe it was Jehu Garcia. He showed this the first time and I thought it was just awesome. He uses a desktop power supply, sets the desktop power supply to the voltage that the batteries is at. And then you basically let everything equalize on that voltage first. And once the voltage is up, and then your amperage trickles down to almost nothing on your desktop power supply, then you can turn on the breakers and let power flow from the batteries. So I turn the voltage all the way down, and on this bus bar, it actually makes it kind of easy because there's this exposed part at the end. So normally you'd have your covers on, so we will clamp our negative down there, our positive up here. We won't flip the breaker yet. I do have all the devices switches turned off, the power switches turned off. I thought I had done it earlier, and I'm glad I double checked because this inverter was turned on. So I'm looking again, off, off, off. So this is turned down. Our batteries were at 52.1 volts. So we will slowly increase the voltage up to 52 volts. 52.1 volts. And you see our amperage here. Hopefully you can somewhat see that. Our amperage is basically leveled out. We have a green light down here on our Lynx Shunt, and I can see there is a green light over here on the distributor. Once all the power levels out, then we should be able to turn on the breakers, and then we can turn off our power supply. So as of this moment, the DC is hot. So if we put our cover on over here, I'm actually kind of surprised that I'm not seeing lights here, but I guess no power is being drawn from the different devices, so I believe we're done down here. So let's adjust the camera so I don't have to keep hunching over. There we go. I feel like I just grew 4 inches. So now let's check our voltage at each of our battery connections. And it helps to be in DC. 52 volts, 52.1, 52 volts, 52 volts. Very cool. Should we turn one on and just see how it sounds? I kind of want to. I kind of want to see what it sounds like. It might not I might end up having to put a communication cable between these two in order for both of these to turn on. We'll try it without it and see, because I know that these are supposed to be set up in split phase, as the paperwork says. So this has a two-way switch underneath. Number 1 is on and inverting. Number 2 is charging only. So let's turn it on to on and just see what it does. Okay, so we're getting a inverter on and absorption blinking light. And in the manual, there's a whole handful of pages on the different blinking light. So there's, what, 2.5 pages on the different blinking light states. I'm guessing that that has to do with communication. So we'll turn it off. Let me go grab one of the communication cables, we'll plug it in, and then we'll turn both of them on and see what happens. So under here we've got 2 VE bus jacks. We'll plug one into one VE bus. And this 6-foot cable is really long. And another into that VE bus. All right, so we see we've got our communication cable here. Now let's turn both of them on at the same time and see what happens. You can't even tell they're on. There's a faint hum. Let me turn off the noise canceling and see if you can hear it. I would imagine you probably can't hear anything. So at idle, these don't make any noise at all, which is just awesome. And we'll look at idle consumption and everything like that. Actually, there it seems to level out at 6.5, 0.65 of an amp. And our voltage is 52, 52.1. So 52.1 times 0.65 gives us 33.865 watts. 33 watts. Holy cow. I mean, that's unheard of for a low frequency inverter. Hello. I just noticed something else. So as I'm crouched down here talking to you and looking up and just kind of being amazed at just the minimal power draw on idle, I noticed there was something else that Current Connected has done to make sure that you wire things up properly. So looking up in here, not only did they put an L1 and an L2 on the boxes, but they also put L1 and L2 inside the units so that you can make sure that even when you pull them out of the box, you know which one is configured for what. So thank you again, Current Connected. I had not seen that until just now. All right, so with these inverting, we should have voltage on AC out 1. But not AC out 2, because I believe by default, AC out 2 is disabled when there is no grid present. Let me do it over here, because it's going to be easier to not fall out of frame. So we'll switch to AC, neutral on line, 119.4. AC out 2, nothing. AC out 1 on phase 1, 119. AC out 2, nothing. And then we will go line to line, 239.1. Ladies and gentlemen, we have power. You get that feeling in the pit of your stomach just before you turn something on after you get it all wired up. It really kind of freaks you out. All right, so let's come over here to the charge controller, and we will turn the charge controller on. And we'll see what that does for actually the overall idle consumption. We'll check it individually, and then we'll check it overall as a system. So if I turn it on, it powers up. And so it looks like it's going to be switching between different displays on power, solar 1, solar 2, and then battery power. And it also gives you a display of a warning, no PV input power. And I forgot, this one actually has Bluetooth on it. I'm not going to use the Bluetooth right now because I'll end up getting it connected to the servo, but still very neat to see. I won't bother panning the camera down again, but you'll hear me talking. So let's check idle consumption now with everything running. It's crazy, it's at 0.62. So because it's not really doing anything other than powering a screen, not really using any power. So what does the manual say for what it should be? I don't see anything in here about idle consumption, but it's obviously... Oh, and the display turns off too. Wonder if it turns off when it's not doing anything. All right, so then let's try this. Let's turn those off. Boy, that's a loud click when that happens. That kind of freaks you out too. We just have that running, 0.0405 volts. So when it's not doing anything, it's got 2.6 watts of that. So these three things running, you're talking 35 watts idle consumption. The 6500s, the manual says 70 watts. Mine clocked at 84 a piece. So 168 watts a piece for 2 units to not do anything. 36 watts. I know people say, Victron's expensive. It's definitely not the cheapest stuff out there, but the quality of these things. I mean, I only ever had the small charge controller, and it just worked. But these are on a whole new level, at least in my mind. That's a lot of unwasted power. Because the 6500s, the fans run all the time. Why are the fans not temperature controlled? These have fans in them. I'm assuming they're temperature controlled or load controlled. We're making huge progress. I'm not going to bother. I've got to do some PV wire combining and stuff like that, and then I got to get them run up into the bottom of the charge controller. I'll get that taken care of at some point off camera because it's just running wires and connecting them. Well, I know it was a longer one, but we were able to get exactly what I needed to get done. We got DC running. We've got power to the inverters. We learned a few new things along the way, which at least I hope you did. I know I did. But now we've got things powered up. I'll get the charge controller all wired in with solar. I'll go through and get the PV arrays all adjusted and everything because this is a 450 volt, 100 amp charge controller that I have now. And it's got 2 inputs. The 6500s each had 2 apiece. So I had a total of 4 inputs. And I have to get down to 2 on this one, and then I'm going to also add my Victron 150/35 charge controller as well. So just some reorienting, rewiring a little bit, get things all straightened out, but we'll get that taken care of, and then we'll get power pumping into these batteries so that we can get off of that 30% that we've been sitting on for a while and use some of the solar that we've been getting. So stay tuned for next time, because we'll see how far we're gonna get with the AC side. I'm excited. I'll be really happy when we can, like I said before, move on to newer things, get to testing the system, see how it's gonna work. But with that, I'm gonna let y'all go. So y'all stay safe, stay cool, and we'll catch up with you later.